In this video, we're going to practice using our fundamental identities. We already talked about these before, but we're going to continue to practice these because they're important. So these are our fundamental identities. Tangent is the ratio of sine over cosine. Cotangent is the ratio of cosine over sine. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So we're going to use our knowledge to practice finding trig values given our sine and our cosine values. So in this question, it's asking us to find the tangent of 45 given that we know the sine value at 45 and the cosine value at 45. Since the tangent of 45 degrees is equal to the sine of 45 degrees over the cosine of 45 degrees, that would be the square root of 2 over 2 divided by the square root of 2 over 2. Since they're both the same, my tangent of 45 would be 1. Now we're going to evaluate secant of 5 pi over 6. Secant of 5 pi over 6 is equivalent to 1 over cosine of 5 pi over 6, since secant and cosine are reciprocals. If I look at my unit circle, cosine of 5 pi over 6 would be negative square root of 3 over 2. Now, when I have a fraction divided by a fraction, I flip and multiply. So this is going to be negative 2 over the square root of 3 because I flip it upside down. And then if I rationalize that, I multiply both the bottom and the top by the square root of 3. So that's going to give me 2 square roots of 3 over 3. In example C, we're asked to find the cosecant. In example C, we're asked to find the cosecant of 7 pi over 6. And unlike the previous two examples, we're not given the information for sine or cosine, but we can look at the unit circle and figure it out. If I swing open in standard position an angle of 7 pi over 6, my ordered pair is going to be negative square root of 3 over 2 and negative 1/2. Since my cosecant is the reciprocal of sine, I'm going to write it like this. In looking at my ordered pair on the unit circle, my y value for 7 pi over 6 is negative 1/2. So when I take the reciprocal, because cosecant and sine are reciprocals, I'm going to get negative 2. Now that we're a little bit more comfortable with trig functions and the fundamental identities, I want to show you where the Pythagorean identities come from and how they're derived. So if we start with the equation of the unit circle, we have x squared plus y squared is equal to 1. But when we're looking at the unit circle, we know that the x-coordinate on the circle is equivalent to the value of cosine. So I'm going to replace x squared with cosine squared. And I know that on the unit circle, my y-coordinate is equivalent to the sine value. So I'm going to replace y squared with sine squared x. And that's equal to 1. And that is where this identity comes from. It's derived directly from the equation of the unit circle. So now what I'm going to do is I'm going to use the first equation, the cosine squared x plus sine squared x is equal to 1, and derive the other two equations. So if I first take and divide the equation by cosine squared x. Remember, when you're working with an equation, I can do anything I want as long as I do it to both sides of the equations. So I'm going to divide both sides of the equation by cosine squared x. Now when I do that, I get cosine squared x divided by cosine squared x, which is 1. Then when I have sine squared x over cosine squared x, that's going to give me tangent squared x, because I know sine over cosine is tangent. So when I square that, I get tangent squared. And 1 over cosine squared is going to be secant squared, because 1 over cosine is equivalent to secant because they're reciprocals. So if I square that, that's going to give me secant squared. So this equation is this one here. So I just took the first equation, which we derived from the unit circle, the equation of the unit circle, and I divided everything by cosine squared x to get this equation here that I just highlighted in green. Now I'm going to do the same thing where I take cosine squared x plus sine squared x is equal to 1, but now I'm going to divide both sides by sine squared x. When I take cosine squared over sine squared, that's going to give me cotangent squared x, because cosine over sine is cotangent, and when I square it, I get cotangent squared. Sine squared over sine squared is 1. And 1 over sine squared is cosecant squared, because 1 over sine is equivalent to cosecant because they're reciprocals. But if I square it, then it's going to give me cosecant squared. So this equation here is this one here. Now that we have these identities, I can use them to evaluate trig functions. So for example, if I said cotangent squared x is equal to 1/2, then I could plug that into 1 plus cotangent squared x is equal to secant squared x, and then I can solve for cosecant squared x. So I can plug values into these equations to solve or find values of other trig functions.